So the first and foremost question I want to put forward, please feel free to unmute and answer this. Why we as data engineers should learn or understand Databricks?
To deliver better cloud-based solutions.
Cloud-based solutions, that's definitely a good answer.
Like less processing time, I guess.
Processing time. Okay. What else? Samir said best to run Spark. That's actually one of the good answers.
Yeah, understand the distributed computing at scale.
Distributed computing, nice.
Automate process flows.
Processing, automation of processing, nice. Great. So these are all the right answers, the answers that I'm looking for. But is Databricks the only solution that is offering all these things? The answer would be no. You see, there are several solutions that came before Databricks, and there will be several solutions that might come after Databricks. But what is so unique or what is so special about Databricks is that if we as data professionals would like to start working with Databricks, it offers end-to-end solutions. When I say end-to-end solutions, right from analyzing the data to working or building something called as ETL workloads. So we'll talk about what exactly ETL workloads in a moment. To building a machine learning model, to a data governance need. So whatever is the idea that you pick up as a data professional, most probably Databricks has an answer for it. And in the most simple terms, we call Databricks as a unified platform. So when I say unified platform, what exactly do I mean? Let's talk about a fictitious company called, let's say, Global Mart, which is an e-commerce company, for example. So what are the what are the things this e-commerce company does? They have an application where they sell products, a marketplace where they sell products from vendors. All of the data is being captured in some place called a database, maybe, for example. Now, in order to enhance the business, they want to bring in analytics. What sort of analytics? They wish to analyze all of this data from this database. They wish to analyze this data from this database. Along with analyzing, they want to build daily or weekly reports of set of metrics, which will be shared to stakeholders, for example, business stakeholders, for example. Along with which they also want to build some sort of machine learning model to predict what would be the forecast of, to understand the forecast of a specific revenue from a specific product category, for instance. Along with which they also wish to store all the metrics in a centralized location, which can be shared with the downstream teams. That could be some business analysts, some data analysts, or some data scientists, so on. So the idea was that when you have such multilateral needs for an organization, as of now, as of today, the tools that you see will only solve either this solution, it will provide a solution for this or this or this or something else. Most of the solutions that is. But what Databricks says is that you do not need to look for multiple solutions for multiple needs of a data company having multilateral needs. Everything is provided within just one single tool, and that is Databricks. Because of its nature of providing multiple solutions in one single place, Databricks has become one of the go-to solutions for one of the go-to places for building your cloud-based solutions, as you rightly said. Because of its nature of providing multilateral solutions and address multiple challenges, we are calling Databricks as unified platform, and that's exactly the reason why this has become one of the favorite cloud-based solutions that we as data professionals have started to. Okay, that was actually the reason why Databricks has started getting so famous. But at the same time, the answers you have shared for running distributed computing or Spark-based workloads, the idea was that there are other solutions that still allow you to work on top of Spark, apache-spark. But why Databricks? Because Databricks have taken that open source apache-spark, made it as its own, added its own optimization layers on top of it to make it much more smooth and powerful. End of the day, either it is a single or monolithic system or a distributed computing system. Databricks supports both of them. And finally, I want to talk about something called as ETL because that is what is at the center of what we are going to discuss for the next 6 weeks. So we'll have a quick introduction of what exactly do we mean by ETL. Then I will talk about automation, or as we technically call it, orchestration. We'll talk about these two things before we move on to the next page. So let's take a quick moment here to understand what exactly do I mean by ETL. For which, let me take up the same case I had talked a moment ago. We have Global Mart, a e-commerce company. Global Mart is an e-commerce company. What is it doing? It is trying to have a marketplace where you have vendors and customers selling and purchasing products. And what Global Mart is also doing is that it has started its own vertical of products, of its own brand of products to sell in the same marketplace. Okay, this is what is a core business of Global Mart, the e-commerce company. Now let's understand how this business is working and how ETL is a way for us to help Global Mart to improve its data systems and its AI systems. So in this context, what is happening? There is a customer, okay, who has registered himself or herself on the Global Mart website. Okay, so a customer is registered. This customer is placing orders to buy some products, from a set of vendors. And in order to place the order, we are doing something called as transactions. This could be an internet transaction, a UPI payment, a credit card payment, so on and so forth. But a customer who wishes to buy a product from a specific vendor places an order, and in order to complete the complete placing of order, we are making a transaction. And where exactly is all of this data is going and sitting? All of this data is being stored in an ACID-compliant database. ACID-compliant database. Now, because we as customers have placed the order, what we would also typically do is that once we received our order, once the order has been dispatched and we have received our order, we would like to place some reviews about the order. You might have liked the order very much, or you might not have liked the order at all. And in that context, what you would do, you will go back to the same product. You will leave a star rating maybe. What you might also do is that if you would have loved it very much, you would take a video of it and you will actually publish this video on this product. What you might also do is some people might also give a text-based review for this specific. Okay, what we have seen over here is, as we call it, a structured data. But what we are seeing over here is what we know, with what we understand as unstructured data. You see, the types of data are varying drastically between the context that we have seen here versus the context that we are seeing over here. Okay. Along with these things, there are several other sources. For example, because they are maintaining their own line of products, they would need their own manufacturing setup, for example, or outsource the manufacturing to some other company. And because they are outsourcing manufacturing to some other company, they would need some ERP tool to plan the to meet the forecast of the specific products. They are using an ERP solution, an enterprise resource planning solution for it, in which there is also some data that is being generated because of placing of orders, tracking where was the order, how much amount of manufacturing has been completed, what part of manufacturing is still left, so on and so forth, which they're tracking entirely in an ERP application. Okay, maybe with this, Global might need some CRM application, some customer relationship management application, in which they're generating some other set of data. But my entire point, what I'm driving towards is that the data that is being generated in this specific company called Global Mart has several sources. If we imagine ourselves at its center, just as a consumer, you are placing the order from a vendor, and for which you are making the transaction, you're also leaving some reviews. And in order to fulfill that order, maybe Global Mart is planning some manufacturing for that specific product, right? There are multiple places this data is being generated just because you're placing one order. There are several thousands and lakhs and millions of customers that you typically see on a traditional e-commerce website. Now, when you have such diverse set of data sources, how would a data analyst or a data scientist or a business analyst would understand what is the data that I have with me? How can I consume this data? We cannot apprehend, we cannot understand the sources, nor we can directly go and talk to all these various sources because these are raw and unclean data sets. And that's exactly where we as data engineers come into picture. What do? One of the most important goals as data engineers is we talk to each and one of these data sources, all the data sources that we have seen up until now. We talk to each and every one of them, get all of the data, put them in a mixer, clean it and transform it. What exactly do I mean by transformation? For example, when you place the order, you will know that on date X, I have placed the order. On date X, I have placed the order. On date Y, the order has been dispatched. On date Z, the courier has picked up the order. And then date A, the order has been received by me. And what would stakeholder want to understand is whether this order has been delayed or whether this order has been delivered early. That is a metric a stakeholder might be interested in. Number of orders that are delayed versus number of orders that are early from a specific vendor. Is the vendor continuously delaying the orders? Is the vendor consistently performing well? All those are various metrics, various KPIs a stakeholder might be very interested in. But how can they get the data? The data is in multiple sources. How can they get access to that? That's exactly where we as data engineers, what do? We extract and gather all of this data, put them in a mixer, clean them, transform into those metrics that the stakeholders might be interested in, and finally put them in one single location such that this final clean KPI and metric-based data is now accessible to downstream teams such as data analysts, data scientists, business analysts, and all these things. Okay. In more simple terms, you're extracting this data and putting it in one single place. You're transforming all of the data and then loading that into a final location. Extract, transform, and load. ETL. And that's exactly what you also do as data engineers using Databricks. Databricks plays a crucial role. Databricks plays an important role in helping you develop these ETL workloads that might be needed for an organization to build an AI strategy on top of it. It plays an important role because unless until you have that final clean KPI-based, metric-based data, a lot of stakeholders cannot take decisions without this specific data. Now, the idea is that in order for you to run this workload, is there really a need for one single person to sit and execute this day in and day out? None of us or no companies would want that. So what we do is that we automate the execution of this extraction, transformation, and loading, also called as orchestration. Orchestration. You orchestrate these workloads, or as you rightly said, you automate these workloads, which is also possible by use of Databricks. But what is Databricks additionally doing? Because there is a high chance this data could lead into, the scale of the data could lead into TBs and ZBs, terabytes and zettabytes, which in other words is what we call as big data. You might need distributed environment. Okay, you might need distributed environment because a single environment, if it fails, all the work that has been done up until that point might be lost. So when you make use of distributed computing environment, the idea was that even if one thing goes down, you can still continue working, you can still continue building your workloads in other servers or other systems. Databricks also supports that. So idea was that Databricks for us as data engineers will help play a crucial role in developing these ETL pipelines and automate them by making use of something called as practice. So at this moment, what I want to simply say is why it is important to learn Databricks, because rather than looking for multiple solutions for multiple problems, Databricks offers one-stop solution for most of the data needs that you as an organization might have. Hence, learning Databricks is getting important, right?